and pieces of this before, and some of you haven't, so I'm going to do everything fairly much from scratch. I won't get into any math. It's pretty high level. There's two demos in here, two pieces of software I'll show you. A lot of if you want the underlying math, there's an appendix in this book, Making Robust Decisions, which I wrote in 2006, and it's a little out of date, but not too awful bad. And you might notice that it says making robust decisions. So I need to talk a little bit about what I mean by robustness. And what I really mean is an insensitivity to uncertainty. And, stuff's going to happen. And some of it you can foresee and some of it you can't foresee. But if you're going to make a decision that is robust, it should be as unsensitive as possible to both the foreseen and unforeseen events that might happen. Now, this doesn't say anything about eliminating uncertainty, because you can't, or you might be able to if you go the right direction. But it does say that you better pay attention to it and better manage it. And so some of the things you might want to be insensitive to is that, and I should really say the first one should be assumed data. We've been talking a lot about using data here, and there's only so much quality that data might have. And so it may be that the data is actually off. You may have courses of action that you're trying to imply on your decisions, but of course deviations do occur. The models that you're using may have limited fidelity. You may think they're one thing, and indeed they may be something slightly differently. Some of the information you might be relying on isn't based on data, but based on stakeholder estimates of information. And you need to get a grip on how inconsistent or how uncertain that is. And I'm going to go into all of this stuff in more detail. A big one that people don't seem to pay a whole bunch of attention to, and I'm going to make a big deal of, is stakeholder values. What do they think is important? Because your different constituencies think different things are important. And if you want to get buy-in from your different stakeholder communities, you better be paying attention to this. And then what conditions really stress your whole model. And so what I'm going to do is build a really simple model of decisions, so you get my jargon, and then we'll do two different pieces of software that support this. So the first one is you got to understand the issue, and sometimes that's a little difficult because everybody involved may not have the same issue. They may not walk into the room wanting to understand the same problem. And you can replace the word issue with question. What is the question we're trying to answer? And so when we in C4UC talk about modeling, I keep pushing, okay, we're building models, but what's the question we're trying to answer? What's the issue we're trying to address? And so I keep coming back to that, because that's the starting point. Now, often when people will talk about an issue or a question, they'll add a lot of ands and ors and buts to it. And all of those things are really measures, if you think about it. I want to buy a car, and I'd like it to hold 4 people, and I'd like to go really fast, and I want it to accelerate, and I want it to get really good gas mileage. All these things about the number of people and the acceleration and the gas mileage, these are all measures of the quality of different alternatives you might want to consider. And so one of the things that can be done if you're facilitating decisions is pay real attention to all the caveats that people put on and all the assumptions they put on when they're just trying to articulate what the issue is. So one of the other things you desperately need when you're doing a decision is you need to have alternative courses of action. Sometimes you'll see decisions, people talking about making decisions when they really only have one alternative, and that's called justification. We saw that in the weapons of mass destruction decision that got us into Iraq. There was really only one option, and the goal that must have come down from on high was, let's justify this. Okay? Now, of course, you could always say, well, there can never be one option, because you're either going to do that or you're not going to do it. So there's really two. But if command on high says we're going to do that, then it becomes justification, not decision making. So So the next thing you have to do is you have to evaluate the alternatives. And you have to evaluate the alternatives against the measures you're using. So if I go into the car place to continue the car model, and I want to know what, I want a car that gets good miles per gallon, I'm going to look at the sticker on the windshield or go read a report or gather some data on how good this particular car I'm looking at actually does the mileage. Now you got to be real careful here, and this is the first time I'm going to bring up uncertainty. If I want to know what the mileage is on a specific car, I have at least 3 major sources for that. Number 1, I can look at the sticker that's on the window. Number 2, I can go to the reports online from different authorities like Road and Track and other things like that. I can go online. I'm going to do 4. I can go online and look at what other people in the social media have said, or I can go talk to my buddy down the street that owns one of these cars. And all these things have, they may not agree. And so I now have to make some judgments. This is now an uncertain number that this car I'm looking at gets 32 miles to the gallon. That's really an uncertain number depending on what source and how I value those different sources. So evaluations also, evaluations can come from modeling. This is where our models come into play. And into those models, we're going to bring in data. And the data itself may be uncertain. It may be inconsistent. It may be nasty. The evaluations may be in terms of estimates. You may not have real numbers for it. You may go to a panel of experts and ask all the experts a question. Well, what mileage do you think this car is going to get? Going to the WMD example, they went to the Intel people and said, well, what estimates do you think, what is the estimate on, do you think they have weapons of mass destruction, which ones they have, all those kinds of things that are going to enter in here. And they got varying information, and then they decided to ignore the uncertainty and made Colin Powell look very bad. Superimposed on top of this is what are these things, which of these evaluations do people think are really important? So I may want a car that accelerates real fast, but my wife wants a car that gets good gas mileage. Or I want a car that I can haul my junk in, and my wife wants a car that looks good or something. We have different value structures. And in the example I'm going to show you in a few minutes, we had very disparate stakeholders that we had to take into account in the evaluation and their values. So once you get that, we're now leading to a decision, but most people think of a decision as choosing an alternative. And I think that's pretty short-sighted. I think the decision is really, what do you want to do next? And there's a really great quote from Arthur C. Clarke, and he said, the only hard decisions in life are what to do next. And I think that's really what you do, because there's a whole bunch of different things that can be done here. You can actually choose an alternative and take action on it. You can address new issues. I'll come back to that in just a second. It may be that the right things to do is reformulate the issue you're doing. You may not be doing the right issue. Or you may want to generate some new alternatives based on your evaluations, or you may want to go back and do some more evaluation. And part of this is trying to figure out which one of these is the right thing to do. So in terms of addressing new issues, one of the things I noticed after working on this for a while is generally what we put up there as measures, they generate the new issues. So what I mean by that is, let's take the WMD thing, for example. One of the measures is, do they have, what's the level of WMDs that they have? Might be one of your evaluation criteria. And, but they may break out as a separate issue all by itself into, do they really have WMDs? So they sort of spawn, these issues can spawn new issues. So this gives you some idea of the jargon. Harry that was here has a much simpler model. He mainly looks at, he worried about the data and the alternatives and sort of grouped everything else together. But this gets us down to much more nitty-gritty. So this is all pretty easy to screw up. and I see this happening all the time. And I mentioned a lot of these when I was presenting it. First of all, the issue isn't very clear. We don't even understand the measures exactly the same. You know, we might not. I mentioned the justification. Poor uncertainty management, we're going to talk about uncertainty management in just a second. Even the measures themselves, that's sort of similar to the poor understanding. Poor honoring of stakeholder values. People seem to really get tangled up between what they're measuring and how important that is to the different stakeholders. They get that all tangled together. I'm going to show you how to untangle that. And then a weak consideration of what to do next. So I'm going to show you a project that I worked on for about 2 years recently. And we called it Bayesian Assessment of Spatial Siting. And what this was done for a government group that goes by the name of Boomra, and I never can remember what Boomra even stands for, but they're responsible for licensing what people do in the ocean off the coast. And one of the things they were interested in is putting wave energy generators off the coast of Oregon. So what wave energy generators basically are devices that somehow, due to the waves going up and down, take energy out of that. And there's all kinds of ways of doing it. There's floaters, there's ones that live beneath the surface, there's ones that rock, nobody knows what's the right way to do that yet. But there's real concern over where you put these, because in Oregon in particular, the coast is all public. There's no private land on the Oregon coast. And if you put anything that's going to screw up the view, there's going to be people jumping up and down. If you put anything that's going to screw up the fishing, people are going to jump up and down. If you do anything that screws up the whales, you know, and go on and on and on. There's all these constituencies, all these stakeholders, all of which have something they think is important about the Oregon coast. And here's some people that want to put something out there in the ocean, bobbing up and down. Maybe you can see it, maybe you can't. And so it's really hard to figure out where you want to put these. But it's potentially cheap energy. So we came up with that there's really 4 types of questions that we had to answer, we had to address, and I've got them listed there. And it could be a planning entity that we're doing, it could be a project developer, it could be government agencies. So things get complicated very, very fast. And do keep in mind while I show you this that I'm just showing you a general decision-making methodology. It happens to be applied to this specific problem. It's perfectly general. It doesn't care the problem. So I don't think I'm going to do these. I got a couple here. I'll put these slides online, but I'll just let you read through these. These are some of the characteristics of an ideal system that might support people making these decisions. And as you can see, we have them listed under how do we want to support the stakeholders, how do we want to support the information, how do we want to deal with uncertainty. And under uncertainty, I've listed that there's many different kinds of uncertainty, and I've mentioned these to other people in C4UC before, and that is the data itself may be uncertain, the model may be uncertain, the information we get from people, the estimates and opinions, and they may even all be inconsistent, which I sort of treat as a form of uncertainty. And this problem had additional specifics, and that is it's a geospatial problem, meaning that what's happening at one place on the ocean is different from what's happening on another place on the ocean. And not only that, it turned out to be even worse than that, because it was also temporal, in that what's happening in the spring is different than what's happening in the fall, because the fish migration and bird migrations, and what's happening during the month because of high tides and low tides, all this stuff changes. To tell you how bad it is, if you want to know the depth of the ocean at any point off the Oregon coast, you may be able to get it. But even if you get it, it's wrong, because it's continuously changing because of sand buildup and sand going down. And so if you say you have a wave energy generator that needs 35 meters of water, well, what time of the day would you like that? What season of the year would you like that kind of stuff? So it gets very, very nasty very fast. So I'll put all this up. You can go to, I have a whole report on all this stuff on my website. And what I want to do is I want to show you two different computer programs. Bear with me a second while I do a little flip here. This is a program that we wrote back in about 2001, and I tried to commercialize it. And it turns out one of the things I knew when I started to commercialize this, there were lots of companies that tried to commercialize decision-making software, and they had all failed. And so we joined that group, but it took me about 7 years to figure that out. So this is not a saleable product, and looks like I'm getting emails in the background there. Sorry about that. Go away. But it gives you an easier. It's easier to explain how the decision making is supported by showing you this tool before I show you a more sophisticated tool. So the way this tool operates is up here on the top. You'll see the issue: find a suitable site for the T20 norm delta. This is a specific type of wave energy generator, so this is a real problem. And then here are the names of different sites. These are our different alternatives, and there's about 8 or 10 different alternatives there. And one of the things to key on here is that the different colors are associated with the different alternatives. So anything you see on this program that's this bluey purple color, like this bar and this point, all have to do with that particular alternative. And so this is the alternatives. Here are the criteria or measures that I mentioned before. And so, and these were not really well refined. We'll look at the second one, low effect on the gray whales. And they had some way of measuring this. And those numbers are dimensionless numbers. I have question marks in there. But the higher the number, the better. And 7.5 would be ideal, and 4 would be a really bad one. And then some of the things we didn't have any way of measuring, like no effect on the harbor porpoise, nobody had a good measure for. That was just going to be stakeholders saying, yep, it looks like it's going to have no effect, or no, it isn't, whatever. And then in this particular example, here are some of the different stakeholders that are going to be working on this. And so we have not only a state government entity, we have NOAA, the commercial fishermen, the bed and breakfast owners, and then I put a separate one in there for scientific data just because it was an easy way to get it in this particular model. So basically, all this information at the bottom is worrying about framing the problem. And often, if I'm facilitating decision making, this will be half the work. It's just getting the frame reasonable. So then what happens is, and I'm going to turn off some things. I just had it all set up here just to impress you with lots of data. And so let's say we're trying to find out what's the effect on a harbor porpoise. We would ask a commercial fisherman, who would be somebody who would probably know if you put something right here, it's going to affect the porpoises, because I see porpoises here often, or I don't see them there at all. But somebody who might be considered a domain expert, we're going to ask their opinion of that. And they're going to put this dot someplace on this belief map. And now you might notice it's yellow because we're evaluating site 8678. It's got the number 6 in it because we happen to be doing number 6 in the criteria. If you think about how many dots will end up on here, it looks like we've got about 8 or 10 sites. We have 7 criteria, and it looks like we have 5 different potential people. So 7 times 10 times 5 potential pieces of information in here. That doesn't mean they'll all be here. I mean, this system runs with a Bayesian underpinning, and if there isn't any data, it doesn't care. It doesn't affect things. So we're just going to look at one data point out of this, 3,500 potential, or whatever it came out to be with the math. So the commercial fisherman's going to say, well, no effect on harbor porpoise. Yes is really good. Yes, it has no effect. That might seem like a double negative, but anything good's at the top, anything bad's at the bottom, and then the level of certainty or knowledge is left and right. So if the fisherman knows a lot about the effect on harbor porpoises, he put his dot over here. If he didn't know anything at all, he put his dot over here. Now you might notice as I'm moving this around, this is bobbing up and down. What these bars are over here is part of the output. And they're the level of satisfaction for each of these different alternatives. So obviously, moving this dot around is having an effect on the overall level of satisfaction that's going to come from comparing this particular alternative to all these criteria. So we're affecting at least some of the evaluation on that criteria. So you can see if he puts it up here, he's saying, I am an expert on harbor porpoises, and I know for a fact that this location is going to have no effect on them. And you might notice that this has popped up to 86% satisfaction. If he put his point down here, he'd be effectively saying, I'm an expert on harbor porpoises, and I know this is going to have an adverse effect on them. If he put his point over here, and you might notice that this has gone down to 74. If I go in the middle here, it's about 78. If I go up here in this upper left corner, you might notice that it stayed at 78, and he's effectively saying, this is going to have no effect. This is going to have no effect on the harbor porpoises, but I don't know what the hell I'm talking about. Basically, we call this the salesman's corner because it's you just don't know too much about what you're doing. Actually, all the data points start out right here, and what we generally find is people that have really low knowledge about something don't ever move them, and you'll find that most of the points end up in this region up here that says, well, the more I know, the more I'm sure in one direction or in the other direction. So they end up almost in this V pattern generally. So if they put the point down here, notice that moving up and down this axis is having no effect on the result. If he put the point down here, he'd be effectively saying, this is going to, what's he going to say? Yeah, it's definitely going to have an adverse effect on the porpoises, but I don't know what the hell I'm talking about. Yeah, this is the engineer's corner because they're pessimists. I thought you'd like that. Because I'm always pessimistic around Brad, so what the hell. So anyway, this point when it started was up in here someplace, and we might notice if we turn on, let's see, if we show all the people, oh, there was only one other person that put in an evaluation on the porpoises, and that was the NOAA people. And they don't agree very much. What the fishermen think is going to be the effect of this location on harbor porpoises is very different than what NOAA thinks. If we go to a different point, here these seem to be the only two people or only two constituencies that knew anything about harbor porpoises. Here you can see they don't agree, they don't disagree too much. There, neither one of them knew much about the location. Here they both thought it was going to be bad. The commercial fishermen said, I know more and I think it's going to be good. Go up to this one. So this seems to be the one where they disagree the most. And one of the questions you can even ask at this point is, do we care that they disagree? I mean, one of the things that happens in meetings of people that are from different stakeholders, they end up arguing about stuff. And the bottom line question here is, do we want to let these two people duke it out about the effect of this location on harbor porpoises? Yeah?
Are they weighted in this model as you're looking at right now, are they weighted the same? So NOAA's voice is the same as the local fishermen's interest? Okay.
Yes.
For the scenario you described, I don't think there's the opportunity to do this, but it occurs to me that if you had the same stakeholders or domain experts repeatedly involved in similar decision making, you could use Bayesian analysis to figure out, when somebody says, I'm really sure that this will be bad, and you say, well, you're full of it.
Yeah, right.
You wait them.
Yeah, that's a really good point. And that, of course, could be done. One of the things, I'll show you in just, both of you hold that question for just a second. There is a little trick in here we can do that does take that in, into account, but there's a manager's, I'll get to, don't let me miss the evaluation management tool, because it will take into account what you bring up. But let's get there first. So if we so it looks like we only have 2 points for each of the on this particular criteria. Some of the others, we may have many more points. If I turn on everything for this particular problem, there's all the points that we have for, and like I said, the sum total could be the number of alternatives times the number of criteria times the number of people. And you can put dummy people in here, like in this particular case when I was playing with it, I actually put the scientific data in as a separate a person just so I could manage the information. And we'll see in the second half of this, the second program, I handled that a little bit differently. But what happens basically is really quite simple. These are all turned into probabilities. A probability of it being satisfactory, the probability of this alternative meeting that criteria ranges all the way from the upper corner over there, a 1 to a 0 down here to a 0.5 along there, and there's a little Bayesian model underneath that does all that mapping. Now, for the quantitative kinds of things, like effect on groundfish, let me kill some stuff here. So here's, go away. So here's the effect on groundfish, and it was on a 1 to 100 scale, and again, I have no idea what the scale meant. I did know that 1 was good and 100 was bad. And so now we can get some data on this on a numerical scale, and when it starts out it says, well, I don't really know what is the effect on groundfish of this putting a wave energy generator at this location. So I'm just going to assume it's a distribution starting at the middle, petering out at each end. These little error bars here are effectively about 3 sigma. But you can see the little up arrow and the little up thumb and the down thumb, they agree with what these targets were. So if I move this point down here, you'll see it'll go up. Let me move these bars closer together. So you can see if I get as good as 1 or better, it's equivalent to saying I know it's good and I have real high confidence. If my uncertainty begins to branch out, you can see that moves, it moves everything to the left. Okay, and then if this point starts to go, I slowly work my way. The reason that the dot's going over that direction is because the uncertainty got greater. Now I'll bring the uncertainty in. So what it does is it allows you to put in actual numerical information on your distribution if you really have that information. So that's why I put in different ways of doing that. So what it then does, it takes all the evaluation information for any particular point, and it calculates an overall satisfaction for that point. Oh, I forgot one other thing. I talked about values, how people value things. The word importance and value are the same, so let's look at that just real briefly. And what this is, here's all the criteria. Here is, for the commercial fishermen, here's what they think is important. And the way this is done is they can move these sliders around, and these happen to always sum to 1. For some of you that have done decision making before, it's like giving people 100 pennies and say you can put your pennies in any of the buckets. Okay, so here the commercial fishermen think the effect on groundfish is really important, and the kelp is less important, and degradation of view is fairly important, and different things. If we flick to somebody else like NOAA, well, they have a very different model of what they think is important. So these are the value structures of the individual constituents. And so what we do is we superimpose that value structure on all the information over here and come up with basically a weighted sum. And so this particular weighted sum has the, let me switch this over. This has the commercial fisherman's value structure on it. This has NOAA's value structure. You can see they differ a little bit. This is the B&B owner. But it's looking like that for all of these different constituencies I've looked at, that the yellow one, the brown one, and the blue one are pretty close to being the same regardless. They're all 3 up there. State planning people, there's a couple others up there, but the bluish and the yellow seem to be the ones that are dominant. And you can actually show all these superimposed on top of each other And so that's not a distribution, that's just showing all of them stacked on each other so you can see where they are. So the obvious question is, we'll go back to just the commercial fishermen, because on here actually the whatever color that is over on the right seems to be the dominant, but nothing's dominating. And so the obvious question is, what should you do next? And luckily there's a button titled what to do next. And what this does is does a value of information evaluation, and it says, well, we need to build some consensus on no effect on harbor porpoise for 8678, and we have low consensus on the low effect on groundfish. We have low knowledge on a whole bunch of other things we might want to do. We might also want to refine these two criteria down here, 6 and 7, which you can't see, and maybe make them measurable because they're qualitative. So here's some places you might want to spend your scarce resources.
That sounds like we didn't like the data, so we're going to change it.
It isn't that you didn't like the data. What it's actually doing is it's saying, okay, the yellow one is not differentiated from this pinkish one or bluish one, and depending on whose viewpoint you look at, and it changes with viewpoint, but these are not differentiated. And if you do something with the information at these specific places, you may be able to make them differentiated from each other. It's not saying whether it'll go up or down. It depends on. So let's just look at one in particular, and you can fairly well guess that I set this up.
So Dave, you're arguing that makes the overall decision more robust.
Well, the robustness comes in a couple different ways. The robustness comes in the number one, groundfish, okay, we'll do the groundfish.
So what to do next is sort of a list of what to do to make the decision.
Well, the robustness is coming in a couple different ways. Number one, the robustness is coming in because we're taking into account the uncertainties to actually get to this. So information that's highly uncertain is discounted from information that's more certain, number one. And then number two, we're trying to aim ourselves at where to build more robustness, to go with you, more robustness by working on the right places. But the real robustness is coming in from taking into account the uncertainty throughout the evaluation. So one of the things it said to do is worry about this. Now, why did it say to worry about this? Well, if I go to the scientific data and say, well, the scientific data is poor and the commercial fishermen are right, okay, you can see that that's really lowering the yellow out of consideration. If I say, well, it's the commercial fishermen that are, they're too pessimistic, that it should really be more, you can see the yellow's going up, and if they said they actually knew more, it'd go up even more. But it gives you some place that's going to actually change it's going to give you the most dramatic changes in the results. So there's two things happening here. One is we're trying to focus the conversation on those things that matter, and we've separated the value structure out so they aren't arguing about their values, because we can look at this from anybody's values. And I've had a group of people in there that I let them do their own values, and then when we started really looking at the data said, oh, pick this one, regardless of whose value, and then they didn't have to argue anymore, unless they just liked arguing.
To Rick's point, it's not about the data that the commercial fishermen need to change their viewpoint. If the commercial fishermen were more certain about that viewpoint, moving it just to the right, then the certainty of the evaluation would be more robust.
And actually, if we go to the different viewpoints now, you'll see the yellow one's no longer in contention. It looks like the blue one is now the best. And if we do a what to do next evaluation, no, it still says you're in a disagreement, but you've already done as much work as you can, so you just ignore this and move on to something else. I wanted to show one other thing. No, don't do that. I hit the wrong thing. I meant to hit evaluation management. Bear with me just a second. Let me. Okay, I just put all the data up there for groundfish, and you can see written next to it is the different people. Let's say that the commercial fishermen, we knew they were full of fish all the time. And so what I'm going to do here is, notice I have include and exclude and how to discount people. So watch the commercial, pick on one of the commercial fishermen points, and watch what happens as I click on this. They just shift over to the left, which effectively discounts their knowledge and takes them pretty much out of the problem as you move them over. So you have a management way of doing this. Since you don't really want to play God because you aren't going to make yourselves any friend, when you turn it off, it all pops back to the way it was, but you can use it as a management tool. Yeah, Rick.
A couple of basic questions. Because of the example you're presenting, maybe it falls outside of what I'm going to say. It sounds like you're really trying to help optimize the decision process that involves a lot of opinion from various stakeholders. And what you've done here is you've taken a sample from each of those, well, commercial fishermen. You can ask them all.
You could have put 25 of commercial fishermen on here if you wanted to. In one of the versions of this, Rick, it's distributed, fully distributed, and I can send out an email message to 25 commercial fishermen and say, here, fill in this form. They fill in the form, we can integrate all their data.
Okay. Where I was going with that was you went through a process of how to try and make some adjustments in here, and the way I heard it was, well, we're going to have a discussion here, and I'm going to see if I can change your opinion, right?
Well, no,
If you do that with a small sample, that doesn't mean you've changed the opinion of the whole.
no, I don't mean change the opinion necessarily. I mean, what may be happening here is that people may not even be visualizing the location the same. People may not even have the same definition of low effect on groundfish. I found that when we get into these discussions, you find people are making different assumptions. And there's no need to change anybody's opinion. You may sit there and talk about this for 5 minutes and decide, yeah, this is where I want to leave my points. I don't want to move them. And then you move on to the next thing. But at least you've aimed them where to have their conversation.
The other thing is it gets the conversations that don't affect the answer get taken off the table.
Yes. Yeah.
And if that's all it did, it
Right,
would be huge.
right. And also by separating out the value structure, you're keeping people from arguing about things. You know, the porpoise are important to me and the whales are important to you, and that's fine and dandy. They're important. Now let's talk about, does this location affect the whales or the porpoises?
Your what to do next, really, I talked about robustness, but really in a sense, it's a sensibility.
It's a sensitivity analysis.
Those things that have the most leverage
Yes,
to move something
yes,
up or down.
yes.
One aspect that you haven't talked about, which is almost like the discounting or including or excluding, but it seems to me with regard to values, if you think of the total space of shareholders, I mean, you're going to have a certain number of respondents in the room, but there's going to be, in many cases, a lot of stakeholders
Unrepresented.
that are unrepresented, and what you might do is, from the set that you actually have, try to use those to,
Now here's what you can do. Let me short circuit you. Let's say we have a big boss. Yeah, I know. Let me say we have a big boss. And big boss is putting in no data at all over here, at all. But we can come over here and say, we know big boss pretty well, and big boss thinks this is important, and he thinks that's important, and he doesn't give a damn about that, and he thinks that's important, close. Now we're going to go over here and look at big boss's. So now all the data that's been taken in is now looked through big boss's eyes. And now I got to leave this demo or I'm not going to get to the second one. Let's see. Let's just do this. This is the actual system we put together. It's called BASS, yeah, since I need to steer. And it's got nothing to do with bass the fish. We couldn't come up with a good acronym. And it just sort of came out, Bayesian analysis for spatial sighting. And it was a placeholder. And it's been a placeholder for 3 years. Don't do that. Don't do that to me. This is all live now on a server someplace in South Dakota.
As far away from the coast as possible.
Yeah, truly. Okay, this is using exactly the same underlying mathematics. It's talking, it's got a very rich, much richer front end. It's talking to the algorithms through an API. And I'm going to go to, you going to cooperate at all?
C4UC demo.
Yeah, well, it doesn't seem to want to. This is not good. Come on.
Smart software.
Oh, wait a minute. That's not good either. That's where it's, I wonder, I bet you I'm offline again. No, this thing dumped me off a little while ago, so bear with me again while I reconnect. So this has previous projects in it. It's working now. Maybe. Okay. It's slow, but it's working. Okay, so this is off the coast of Oregon. I happen to live right by the A in Salem at this point, for whatever that's worth. And here's 5 different locations that they were considering. And notice across the top here, we have defined project, select location, scientific measures, stakeholders, evaluation, results, and report. So we just selected locations. It's easy enough to add new locations to this. I'm not going to take the time to do that. Now, what was important here is there's lots of scientific information about whales and other kinds of fish and fowl and all that kind of stuff. And what we did was we built causal Bayes-net models for each of these. So we actually have underneath each one of these, for every location on here, we can run a Bayes-net and get effectively the same kind of information that in that previous one I was doing by putting dots and moving sliders and stuff. But it's based on real science. It's based on the uncertainty in the models from the data. We happen to, instead of using a Monte Carlo, we used Bayesian, but it gives the same kind of information. So in a C4UC context, we'd run Monte Carlos to get the data to power the things that are measurable, which we're doing here by the Bayesian. And then for the different stakeholders, come on, it's a little slow. We can define the stakeholders, and we have a list of all the people that have participated before, and we can build, a list of people that are making the decisions. And since Brad Holt's the boss of C4UC, why not? We can also define measures that are not scientific measures, but are the qualitative measures. In the program I showed you before, they were all in the same area. Here they're in different areas. Your web keeps dumping me. Come on. That's not good. Anyway, we have defined measures. We can invite stakeholders. This will send out an email to people and ask them for the evaluations. Ask them also for what they think is important. My apologies for the web not cooperating. Let's see if it comes back around. It's not looking promising. Oh, wait a minute. It's always fun doing demos over the web live. So then we get to evaluation results. And where I had the bars on the other program I showed you. Yeah, I'm not convinced I'm totally logged in here. It'll show relative satisfactions for each of these locations, and then you can change the viewpoint. You can change who thinks what's important. It's way behind. This is just the my apologies for the web here. But it's got the same kinds of inputs and outputs as the other program I showed you. It's just this has a much richer front end. And for C4UC, what I would see doing is making a specific front end for whatever problem that we're solving and just do the underlying analysis. And usually I have much better luck over the web doing this demo that I'm having now. Okay, so here you can see that it looks like they're all at 50%. I'm having trouble getting data back from my server, so they're all showing the same thing. But here I can select different viewpoints if I want to, and really begin to tease out which of these locations I might want to do.
One of the things you can look at is, if you look at Dave's priorities and my priorities, which are not the same, you'll see that there are different suitability results.
Yeah, there won't be right now though, but
when you do that, then what you do first thing is you throw away all the ones that don't satisfy either of us.
And move on.
And then concentrate the argument on what's remaining.
right. And there is a what's next analysis here, which actually never quite got done in this particular project because we ran out of money. But it's the same kind of underlying analysis that I showed you in Accord. Yeah, Rick?
I wasn't here this morning or yesterday. Give me an example, a couple examples of the types of decisions you'll make at C4UC that will use this.
Well, one of the things we're looking at right now has to do with healthcare investment decisions. So we're working with a partner that advises Wall Street people that are making investments. And to date, to the best of my knowledge, they've used primarily value of information type, dollars only type of information to make those decisions. But our partner has much richer information that they can bring to those decisions. And so they're looking for a way of how do they accumulate all that information and help their customers make better decisions.
Okay, can I rephrase that as saying?
Please.
You're not using this tool internally at C4UC to figure out what to do at C4UC. You're using it to solve client problems. Okay.
That's so that they pay us. Please.
This question came up earlier, and the snide but accurate remark is, this is a tool for making decisions when you have a choice, and where we are internally at C4UC is a path that doesn't have branches on it yet.
Yeah, that's pretty much the case. So sorry, I always take a risk when I do the online demo, which is why I do the local demo first. And it didn't quite go as I had hoped, but I think you get the general idea that we can put a different wrapper. And as I said, the compute engine's now on an API, and so you just call it as needed and shuffle the information back and forth. And yeah, John.
So imagine instead of this example, the example was healthcare,
Yep.
and there were some trigger points or decision points,
Mhm.
or something coming up, some changes that
Mhm.
might be there. And you're trying to make the best decision as to what to do next. Would you then, sort of addressing the question you have behind this, you sort of alluded to this, a modeling and simulation capability that was running a variety of Monte Carlo type simulations, probabilities of this occurring, that occurring?
We might, well, there's a couple things we could do. Let's, for example, let's say that one of our measures was something that we were just going out and getting expert opinion on. And it came up as something really sensitive. And so we're saying, well, we don't really trust our expert opinion because these experts aren't agreeing. So now we go over and say to Mike, hey, do we have some models that we can now model this system and come up with some much better, much tighter information on in order to satisfy that need. But it's going to aim us at the things that are worth doing, not the things that aren't worth doing.
Another way of interpreting this is there's a lot of research that needs to be done. And many of the aspects of the decisions that face, particularly those that face large corporations and governments, are about building consensus about the direction that needs to happen. And so this can quickly identify which areas need the most reduction in uncertainty, because they're the ones for which the results are most sensitive. And it can direct where the research goes forward.
And we may not be able to reduce the uncertainty. I mean, it may be, it's just the way it is. It's uncertain. Yeah, it may not be resolvable. I mean, you may be able to model it to death and still have that uncertainty, and that's just the way it is. You look troubled.
I was trying to think, well, not so much trouble, I think this is a reasonable question at this stage.
Well, I thought it might be indigestion, but I didn't go.
Have you considered trying to take an approach like this and for a fully, to automate some decision making? I'm thinking, for example, when people look at battle management for systems or systems engagements, you wind up having a bazillion decisions that need to be made, and many of them faster than humans can react. And I think if you can, use something like this to load in advance from various stakeholders and such what the priorities are, you might come closer,
It's doable. I mean, there's nothing saying you can't do it. The wrestling match I'm generally in when I work with scientists and engineers, and keep in mind I'm a PhD engineer, so I know where I'm coming from on this one. We think we can model everything, okay, and therefore all these problems reduce to optimization problems. Plug it in, do the first derivative, see where it goes over the peak, and you're done. Okay, and of course reality is never that way because of all these uncertainties that are involved in the situation. So I'm always very reluctant about, unless you're really confident about the fidelity of what it is you're modeling, about just turning optimizations loose. They generally are not very robust results. It can be done. I mean, mathematically, it's not hard.
Thank you
Chris.
for this. I expected a little bit more Bayesian rhetoric than we got.
But I told you yesterday, I'm not a Bayesian.
Yeah, but
You want more?
but
I can
yeah,
do more Bayesian rhetoric.
You use it underneath, and one of the ways in which I think we make really bad decisions that Bayes helps us on in a very deep way. There are really two advantages. One is it tells us how to combine information in a formally rigorous way. And number two, it encourages us to keep as independent as possible the various components of any decision that we make. And I joked with you yesterday about the WMD in Iraq example, and that's a case, and I actually saw on your website reference to a project you did with the intelligence community that I suspect is very much along these lines. The standard CIA intelligence agent now, intelligence analyst now, owns the problem. She or he owns all of it. And in one sense, that's a recipe for ensuring that all of the information is brought to bear, which is a good thing. In the opposite sense, it's a recipe for ensuring that bias runs rampant and that estimates about aluminum tubes, for example, influence one's estimates about claims or counterclaims about yellow cake, and those are public examples, so I can talk about them, and you can read about the president and the vice president on this issue in the Sunday New York Times Magazine, which you'll see on Sunday. But the reason I think Bayes provides such an important lesson for us in that context is that it used properly, it demands that we keep as separate as possible and rigorously separated as possible those kinds of component decisions. Now, there's nothing that says you can't do it both ways. You just can't have the same people in the same system doing it both ways.
Right.
So how does that advantage and set of advantages of that decision-making framework, which is under the hood here, pop out and become advantages after the fact?
Well, I'm going to answer your question circuitously and then tell me if I've answered it.
Okay.
I taught engineering for 40 years, 30 years, some of them, a whole lot of years. And whenever I started talking about probabilities in any way, everybody's eyes glazed over. And these are engineering students. And I've talked about probabilities with engineers, and their eyes glaze over. And if engineers' eyes glaze over at probabilities, everyone else does. So one of the assumptions we made coming into this, you will notice that I never really talked about probabilities. I stayed away.
The probability button.
I know that. Don't worry about it. I'll erase it for you. We didn't talk about probabilities because people can't estimate probabilities too awful well. They just have no good feel for it. So, and I did none of the Bayesian because even though I've been reading up and studying on Bayes for 15 years, I still can't do Bayes' very simple theorem on day-to-day as I'm walking through life. And I don't know many other people that can either. So these things tend to get in the way. So when we wrote this program originally, we said we want to keep all that under the bedclothes and try to make something that's just brain dead simple, that just has symbols and colors and really simple stuff to deal with because that's all people can deal with.
I think you're underestimating us.
Put the probability.
You've been at this institute too long. I mean, I'm dealing here with, on this one, I'm dealing with fishermen, I'm dealing with tree huggers and whale huggers and real people. I'm not dealing with people that are at the Santa Fe Institute. And I think it's very different.
Oh, wait a second. I was going to say, I've actually, I think it's the language one uses. You can use Bayesian and just translate it to their language of chances and instead of using probabilities. And so I think that...
Yeah, I've read that. I've read those books too, yes.
What?
I've read those books too, and I've still never been able to do it. Okay.
Some of them as well. I mean, I lived in Seattle for 2 years, so I've worked with some of them as well. I agree with Chris. Don't underestimate folks. It's sometimes just being able to translate. It's just like I wouldn't come in here talking Latvian and expect you guys to understand me or for me to be understood. So I just think that it's the same thing.
I think that there's a different point here, and that is if you ask somebody what's the odds that they, what's their chance with this new job offer they got or this new client that they're about to close, and they say 60%. If you track how many times they said that and look at that against the number of times that they've closed, that number wouldn't be anywhere close to 60%. I think that the fundamental understanding of what chance and probability are for most people is that they do not have an intuitive understanding of it to the point that you cannot count on the information that you're getting. And even for people who know the issue, it's like budgeting. The number is always going to exceed the budget that you're playing, even when you take that into account.
But that's one of the reasons for going out and collecting data from a lot of people, which these allow you to do. Now, I can bring any of that stuff to the surface. I mean, it's all under there. It can all be brought up. But we made the decision pretty early on to hide it all, and there was a lot of evidence that that was the right thing to do. And in spite of that, we couldn't sell this.
I do think that there's a lot of value in being able to work without exposing that. Sort of to underscore the point you were just making. I was playing pool the other day with a guy that's one of the best players in New Mexico. And if you know anything about pool, there's a lot of estimation of probabilities and, of the various potential outcomes. What if this doesn't go in? Where does it wind up? How did it? And he's very, very good at making those decisions. But he can't talk about that.
Right. Right. It's all encoded in him, yeah.
I put the Bayesian concepts in terms of walking through life and playing pool and such in the space of effortful learning, which is that you have to run through this loop and learn every time you run through the loop over and over again. And most people don't want to do that. I'm in agreement with
Yeah.
It's hard work.
Yeah.
Tiger Woods does it.
You know, I think maybe the most important thing that your process does, you've got a rigorous mathematical underpinning, so it's defensible in that sense with a scientific judge. But your primary focus is on bringing the stakeholders together, letting them see what their value system is, and where.
Which is nothing original either, but
Right.
it's really hard to do.
Right, it's been pulled together in a nice way. I've seen this same sort of thing used with simulation tools, all the stakeholders in the room, and they're changing the levers this way and that way to see the implication of, in particular, groundwater issues and things like that. You get a lot of, not in my backyard kinds of decisions that come about when you've got all the stakeholders, and people are truly locally optimizing for themselves. So seeing a group of stakeholders all there together and seeing the bigger picture helps them at least accept that their voice was heard, even if they don't like
Right,
the
right. And one of the, go ahead and then I'll make my
Yeah,
point.
when they're locally optimizing for themselves, they're not. They're locally optimizing within their horizon for themselves. And it's by putting this big picture together that they can understand that by doing what's in their vision, they're actually hurting themselves in the long run.
One of the ways of getting buy-in and getting people to join in on the decision and take action on it is for their voices, for them to think their voices have been heard. We're all big boys and girls. We all know that maybe the direction we want things to go, they may not go. The community thinks it should go some other way. But if we haven't been heard, we're not going to buy into it at all. If we have been heard, at least we may buy into it.
We talk about systems thinking as being able to get up above and get a very large view of all the different aspects. And I see this tool
Yeah.
as something that helps a group of people
Right,
move up into that larger
right.
realm of systems.
And as Rick knows, I'm a systems thinker, so not a surprise. Okay, I'm
Okay.
done.
Thank you very much.
My pleasure.
And for more information, DaveUllman.com and C4UC.org.
And I'll send you a little packet so you can put online for
And
anybody
the slides
interested.
that you showed initially here, I mean, you had a diagram in the beginning. I really want that one.
Okay, I'll send you a copy of stuff.
To me, it, okay, thank you.
Would somebody who's near it just press stop on the recording?
The red button
Nope,
No,
nope,
no.
nope,
on the computer.
on the screen.
Laptop.
There you go. Thank you.
Excuse me, can you dive under there and pull the plug on this guy?
With the mouse.
You might need a mouse.
Thank you.